When my muscle memory for a piece becomes good enough, I like to watch my fingers as they move. Each finger has 3 degrees of freedom, meaning it can only be moved like this, and this. The thumb is an extra movement, as you can also flex the phalanx at the top for a combined 32 degrees of freedom across both hands. That's a lot of movements, actually more than even some very complicated robots like Atlas, which only has 28. This fact made me ask a very weird question.
Could I play a robot? Here's what I mean.
This is a player piano. It plays itself, and to make it work, you just get a roll of perforated sheet music, load it, and watch the music come out. This is a biped robot, and it's not so different from the player piano. This is the animation it's playing. It's sheet music, if you will. It dictates how each motor should move over time. To make the robot walk, you load the file, press play, and watch the gate unfold. But when I say play a robot, I mean doing a real-time performance, using my hands to have complete control over each minute movement, allowing me to improvise and adapt to new situations.
As I will soon discover, the rabbit hole I had just unearthed went very deep. Today, I'd like to show you my journey down it, and hopefully bring something back at the end. This is Project Homunculus. So, first things first, I need some sort of musical instrument, that is, some way of converting my hands movement into robot movement.
The first thing I tried was camera-based hand tracking. It's pretty good, but the only problem is that the resolution of the hand tracking is limited by my camera's resolution, which in this case is not that good. The other problem is that it doesn't work in the dark. The Leap Motion solves that problem by using infrared cameras. It's pretty good at hand tracking, but not so good at tracking individual fingers. Also, when it comes to controlling our own body for, say, walking, we rely less on vision and more on feeling the forces acting on our legs. And having that information on my fingertips would make control way easier.
What I need is force feedback VR gloves.
There are so many choices when it comes to VR gloves, and that's probably because we're still in the Wild West phase of VR. I decided to reach out to the literal first result on Google Images, and after a bit of email back and forth, a Dexter Robotics representative asked me if I had a budget. I naively said no more than $500, to which he replied, "Martino, sorry, your budget is too low. You need to make it 100 times bigger." What the fuck? And no, they're not the only expensive ones. Far from it, in fact.
Oh, hell no, man. What the fuck, man? Get your ass on.
To be fair, there is one really good VR glove, and that is Lucas's very own open source force feedback VR glove.
But his gloves only have 10 sensors total across both hands, which, although impressive, is not even enough to control simple robots like Spot, which has 12 unique motions, by the way, 3 for each of its legs.
So, the only option I had was crafting my own VR glove, and so I gave it a shot. Complete. It's finally complete. If you look closely, there's a blue device at each joint. These are potentiometers. This is an Arduino. It allows me to communicate between potentiometers and my computer. I forgot to record this, but I ended up breaking the thumb, and I also soldered a potentiometer here, which means that we can actually read the values coming from it. As I turn my knuckle, you can see the values on the screen change. It's a bit noisy, but it definitely works. Which meant it was now time to wire everything up and make a new glove in the process. God, this thing looks hideous. I think it's time to acknowledge that I'm really shit at soldering. I have wired it up. It's kind of messy, and in theory everything should work out. Spoiler alert, it did not work out at all. You see, there are two problems with my design. First, potentiometers are only designed for lateral motion, and I need them to be arranged like this, making the bottom one receive a lot of strain, which breaks them super fast. Pots also degrade naturally with use due to something called PODE. So, my design is kinda trash, and I probably wasted a lot of time.
But then I found something.
The goal of the FOB GCC is to provide Melee players with a controller that does not suffer from potentiometer oddity degradation effect, or PODE, while being adjustable to each player's needs. It negates PODE entirely by replacing the potentiometers with Hall effect sensors.
We're replacing the potentiometers in the controller with fucking magnets.
And first of all, hold your horses for just a second and look at this cool Hall effect sensor. It's a tiny little thing, and fittingly, if I take a tiny magnet, hook up the sensor to my computer, I can actually change the readings of the sensor by moving the magnet closer or further away. Now I can also change the readings by rotating the magnet. As you can see now they go from 400 to about 200. And that is because the magnetic field of a magnet is stronger at the poles, which means that I can now measure the angle of the magnet relative to the sensor, and that's what I'm going to be using to make the glove. So, let's go. Hey, so I just wanted to give you a closer look at the glove. As far as I know, this is the first Hall effect glove that's ever been built. So you can see the magnets here, and in fact there's one at every joint. And the way it works is, by rotating my knuckle, I'm also rotating the magnet relative to the Hall effect sensor, which is this box here, with wires coming out of it. And doing that changes the voltage, and I can read the voltage and infer a different angle. And this is of course done at every joint. Okay, now time for a little demonstration of what the glove can do. So this is just standard VR glove stuff. So as you can see, there's a hand representation of my hand. And yeah, as you can see, all the fingers are functional, and each degree of freedom is working as intended. Here's the thing. Theoretically speaking, I should be able to control 16 motors with this glove, but I'm not Franz Liszt, so let's start with like 5.
Bastardo, non mi hai tenuto la fetta di pizza.
No, te l'ho lasciata, è nel forno.
Grande.
The robot arm you're seeing here has 5 motors. One is for gripping and the other is moving in space. I'm controlling one motor per finger, using the thumb to grip. To do this, we're using a 16-channel PWM module for Arduino, which is able to control up to 16 different motors. This number is very convenient, as hands can output 16 different motions. So all I'm doing is taking the angle data coming from the glove and feeding it directly to the robot arm as a string every few milliseconds, which allows me to do this. Now, let's step it up a notch. As I said previously, robot dogs usually have 3 motors per leg, and my non-opposable fingers have 3 degrees of freedom each. Furthermore, the shape of fingers very closely resembles that of a leg, so my control scheme is, for each of my 4 fingers, mapping each of the 3 sensors to the corresponding motors. Let's get onto the title of the video now. This is the force feedback glove prototype I'm working on. By placing a tiny motor at each joint of the finger hold and through appropriate gearing, it can provide active force feedback for every single degree of freedom of every finger of your hands. Current VR gloves use resistive force feedback, which basically stops your fingers from moving at a specific distance, allowing you to feel the shape of things, but not their weight or how soft or hard they are. However, you can already see the shape of an object just by looking at it, so this is not very useful in the sense that it's not adding any new information to your experience. Active force feedback, on the other hand, pushes actively onto your fingers, allowing you to feel textures, weights, and more generally, forces. Forces are hard to see with the naked eye and allow for a mutual interaction to take place between you and the environment. My plan is as follows. Get force feedback for every degree of freedom of the glove and use it to control a virtual humanoid in VR. I've already developed a Steam VR driver which allows me to control a pair of hands using just my thumbs. If I were to use a full active force feedback glove to do this, it would effectively capture a possible force that your arms could experience in-game, turning your thumbs into fully fledged virtual arms, further blurring the lines between the virtual and the real.